Hello, Dr. Salunke here. I just received a very strange case file in the forensic lab today. It said someone killed the legendary Royal Enfield vibration. A CP sir informed me that there are multiple suspects involved. And before the case grabs everyone's attention, we need to track down the main killer. I have a lot of evidence to show you. So buckle up because we have a long way to go. But before we open the file case, we need to study our victim. What exactly was the Royal Enfield vibration like? And why were people so obsessed with it? Imagine you are riding an old bullet flat out on a highway. Suddenly you can't even feel your hands. Your boots buzz against the foot pegs like angry bees. And if you ride long enough, metal boots literally shake loose and fall onto the road. For nearly 70 years, that was the reality. Those motorcycles were beautiful. They had souls. But they also shook like crazy. Riding one past 80 km per hour wasn't just a simple highway ride. It was a workout. But today, something impossible has happened. If you ride the new Royal Enfield like Himalayan 450 or the new Classic 350, the shaking is completely gone. Zero vibration. You can cruise at 120 km per hour and mirrors remain perfectly still. So here's our $1 million mystery. How did a company famous for building shaking machines suddenly figure out how to build a super smooth motorcycle? Who killed the vibration? Let's start with pure power loss. Because to understand why older Royal Enfield vibrated so badly and struggled at highway speeds, we have to start with the very bottom part of the engine. Welcome to the case file number 1, the oil trap. At the bottom of every engine sits something called the sump. Think of it as engine's oil reservoir. This is where all the engine oil settles when motorcycle is parked. Now here's where things get interesting. Older Royal Enfield engines had a major problem. The lower position of the crankshaft assembly rotated directly through this pool of oil. Imagine trying to sprint through a waist-deep water. The faster you try to run, the harder water fights back. That's exactly what was happening inside the engine. In engineering terms, it's called drag. At 8000 rpm, those spinning components were cutting through thick engine oil. It stole power. It made the engine feel heavy. It made it feel noisy. And there was another problem. Those spinning parts turned the oil into foam. Here's something many riders don't know. Oil mixed with the air bubbles cannot protect engine components properly, and over time that means increases wear. But when we examined the new 450 engine of Royal Enfield, we discovered something brilliant. The criminal built a wall, a solid partition separating the oil component from the oil sitting below. The crankshaft no longer has to fight its way through a pool of oil. But wait a second, if the oil is trapped at the bottom, how does the rest of the engine stay lubricated? That's where the second suspect enters the investigation. The vacuum pump. The moment oil reaches those moving components, the vacuum pump immediately pulls it away and sends it back to the partition. The result, the rotation assembly spins with far less resistance, less drag, better efficiency, more usable power. And because of this divided design, the engine is literally split into two separate oil chambers. That's why motorcycles like Himalayan 450 actually have two oil drain plugs underneath. So, suspect number 1 wasn't trying to kill the vibration directly. It was eliminating wasted power. The engine could finally breathe freely. But crime of this magnitude are rarely committed by a single suspect. Alright, we found our first suspect. The engine stopped wasting power. But that still doesn't explain the earthquake happening between the rider's hands. Because here's the real question. Why do motorcycles vibrate in the first place? So welcome to the case file number 2, the heart rate stabilizer. At the heart of the motorcycle like Classic 350 sits a single cylinder engine, and the single piston has a huge responsibility. It has to do almost all the work. Every time the piston shoots upwards, it creates force. Every time it slams back down, it creates force again. Thousands of times every single minute. Imagine holding a heavy hammer and swinging it up and down repeatedly. Soon enough your arms start shaking, then your shoulders, eventually your whole body feels it. That's exactly what older Royal Enfields were dealing with. This massive repetitive force had nowhere to go. So engineers simply bolted the engine directly to the frame, and all the vibrations traveled straight to the rider, then handlebars, to the foot pegs, then to mirrors, finally to you. So how do you stop something this violent? You fight force with force. Royal Enfield introduced a new suspect into the engine, a balancer rod. This heavy rotating component is precisely timed against the movement of the piston. When the pistons move upwards, the balancer rod generates an opposite force. When the piston challenges direction, the balancer rod responds accordingly. The force begins cancelling each other out. The violence that once escaped into the motorcycle gets trapped inside the engine itself. Before it can reach the frame, handlebars and the rider, the legendary Royal Enfield earthquakes started disappearing. Case file number 2 points directly towards the balancer rod as the main killer of physical vibration. But my detective instincts are still tingling. Physical vibrations weren't the only problem. There was also the noise, a terrible annoying metallic rattle. If you have spent enough time around motorcycles, you know exactly what I am talking about. The click-clack sound echoing from deep inside the engine. Welcome to case file number 3, the synthetic vocal cord. Hidden inside the engine is a timing chain. Its job is simple. It keeps the bottom half of the engine synchronized with the top half. Everything has to happen at exact right moment, because if timing goes wrong, the entire engine suffers. But years of constant heat cycle take their toll. The chain slowly stretches little by little, and once it becomes loose enough, it starts slapping against the inside of the engine. That slap becomes the rattle sound riders hear. Older systems relied heavily on spring-loaded tensioners to keep that chain tight. But springs weaken with age. Eventually, they lose efficiency. Royal Enfield decided that wasn't good enough anymore. For the newer generation, they introduced an oil-powered chain tightener. Instead of relying only on a spring, it used the engine's own oil pressure. The tensioner is connected directly to the oil system. The moment you start the motorcycle, oil pressure goes to work. As engine speed increases, oil pressure rises. More pressure, more control, a tighter chain. The system continuously adjusts itself based on how engine is running. Quietly, automatically. The chain remains under control. The rattling is dead. The engine suddenly sounds refined. But now, my forensic instruments are showing something unusual. Heat. A lot of heat. The engine is smoother, quieter, and capable of high speeds. By all logic, it should have cooked itself from inside out. So, who gave this engine its fireproof armor? A quiet engine is useless if it melts on a highway. Which brings us to the next piece of evidence, the signs of heat. Welcome to the chapter number 4, the Porsche Skin. Wait a minute, does that mean Porsche is somehow involved in the local crime? Let's look into it. Inside every engine, metal components move against each other thousands of times every minute, and this generates heat, a lot of heat. Older Royal Enfield engines relied heavily on cast iron. Cast iron is strong, durable, it can take abuse, but it has one major weakness: it doesn't get rid of heat very effectively. And when an engine can't shed heat fast enough, temperature rises, components expand, performance drops, eventually things start going wrong. To build a modern high-performance engine, Royal Enfield had to move towards aluminium. Aluminium is excellent at dissipating heat. It cools down quickly, keeps temperature under control, but aluminium introduced a completely different problem. It's soft, very soft. If an aluminium piston continuously scraped directly against an aluminium cylinder wall at 8000 rpm, the engine would destroy itself in no time. So how to get rid of aluminum's cooling benefits without sacrificing durability? The answer came from the world of motorsports, a special coating called Nikasil. Nikasil first gained recognition through the high-performance racing components and Porsche engines. Royal Enfield applied an ultra-thin layer of coating inside the aluminum cylinder, a layer thinner than a human hair. Its surface contains microscopic pores that holds tiny amounts of oil extract where they are needed, creating a constantly lubricated interface. Instead of metal grinding directly against metal, the moving parts glide across their protective surface. So, the Porsche skin didn't kill the vibration, but it made their entire transformation possible. It allowed the engine to run harder, longer, and faster without turning itself into a molten metal. Now we have a smoother, quieter, and heat-resistant heart. But even the strongest heart is useless inside a weaker body, which means our investigation now moves from organs to bones. Let's open the next file. If you take a powerful engine and bolt it into a frame that flexes under pressure, you still end up with a motorcycle that feels unsettled. Welcome to case file number 5, the GP skeleton. The frame is the motorcycle's backbone. It connects everything together: front wheel, rear wheel, suspension, engine, everything. Older Royal Enfields used traditional frame designs. The engine sat inside the chassis, while the frame handled most of the structural load, but pushed the motorcycle hard enough, especially through the corners, and the structure could flex. This resulted in wobbling and uncertainty, a motorcycle that never felt completely planted. So, Royal Enfield made a serious decision. They brought in outside help. They called Harris Performance, one of the Britain's most respected motorcycle engineering companies. The same people responsible for building race-focused chassis for some of the sharpest motorcycle in the world. And they changed the philosophy completely. Instead of treating the engine as something the frame simply carried, they made engine part of the structure itself. The engine stopped being a passenger. It became a load-bearing member. The frame and engine started working together as one rigid unit. The motorcycle became stronger, more stable, and more predictable. Flex reduced. Confidence increased. Suddenly, motorcycle that looked traditional started handling like modern machines. Interesting, right? This is the second time we have seen Royal Enfield build its own body. First they transformed the heart, now they have reinforced the skeleton. The motorcycle feels stronger than ever. But a body doesn't move this intelligently without one final piece of puzzle, a brain. And according to our evidence, we still have one file to check. Our final piece of evidence isn't made of metal. It isn't part of frame, and it neither sits inside the engine. It's made of code. Welcome to case file number 6, the brain mapping. Modern Royal Enfields use something called electronic throttle. Years ago, twisting the throttle meant physically pulling a steel cable. Your wrist and the cable moved. The engine responded. Simply mechanical, but not anymore. Today, when you twist the throttle, you are sending a digital message to the motorcycle's brain. The brain receives the signal, understands it, and decides exactly how the engine should respond. And once a computer enters the picture, everything changes. Different riding modes, different personalities, and different behaviors, including something called eco mode. Now, most people think eco mode works like this. You switch it on, the bikes become slower, the engine loses power, you save fuel. End of the story. And in city traffic, that's mostly true. The throttle response becomes calmer. Fuel efficiency improves. Everything feels relaxed. But according to our investigation, Royal Enfield's engineers hid a brilliant little secret inside the code. The motorcycle's brain is constantly watching what gear you are in. First gear to fourth gear, it keeps the power delivery restrained, helping you save the fuel in everyday riding. But the exact second you shift into 5th or 6th gear, the computer secretly turns off the eco mode. Think about it. If you are riding in 6th gear, you are probably not stuck in the city traffic anymore. You are most likely out on the open highway. And if you are on a highway and a truck suddenly drifts into your lane, you don't have time to navigate menus. You need more power. Immediately you twist the throttle and go. So the motorcycle quietly unlocks the full potential in the higher gears. No warnings, no notifications, no drama. You get the fuel savings you wanted in the city and the performance you might desperately need on the highway, all managed silently by a tiny computer chip. So our final suspect wasn't hiding in the engine. It wasn't hiding in the frame. It was sitting in plain sight inside the brain. But now all the evidence is finally on the table. The only question left is who was the real criminal? Let's deliver the verdict. The autopsy is finally complete, and the answer is Royal Enfield. Yes, Royal Enfield killed its own vibration. It was a planned inside job, and they even bought in outside hitmen like Porsche and Harris Performance to help pull it off. But tell me honestly, wasn't it necessary? To survive in modern market and compete with increasing rivals, the old beast had to die, so a new one could live. And maybe the crime actually saved the riders. So officially, we can close the case and declare that there was no foul play. For decades, the charm of Royal Enfields was deeply tied into its flaws. The vibration, oil leaks, and defaming mechanical clatter. Riders romantically called it character. But nostalgia is a dangerous business model. Eventually, the world moves on. Royal Enfield didn't just bolt a digital display onto an old shaking bike. They didn't simply update the headlight and call it a progress. They rewrote the formula by combining Formula 1 inspired cylinder technology, race-bred chassis philosophy, intelligent oil systems, reverse spinning balancers, and brilliant computer mapping. They solved a crisis that had haunted them for 70 years. They built a machine that delivers the refinement expected from a modern motorcycle, while protecting the unmistakable Royal Enfield soul. The legendary thump remained, the character evolved, and the vibration eliminated. Finally, they became just another cold case file in the forensic lab. ACP sir, the case is closed.